Hi everyone. We're going to begin today's session. It's chemistry GCSE. We're going to be focusing on covalent bonding, simple structures and giant structures. To begin with, we have these questions here which recap ionic bonding, which is what we did in last week's first session. For those of you that were in last week's session, you'll be familiar with this. I'm just going to leave this here for a minute for you guys to attempt these questions. And then at 6:30, we will begin. The answers will follow. Can people just let me know? Is the sound okay? Perfect. Thank you. Your mum is my dad. Appreciate that. All right, it's 6:30. Let's go over this. So these questions you can find at the end of every single video on KayScience, okay? So you have this video bar to the left and you can select all these videos. At the end of every video, you can see we have these questions. Some of them are comprehension questions. Some of them are exam style questions. For example, what is an ionic compound? That's a comprehension question. But what is an ionic bond is a 2-mark exam question. What is a giant ionic lattice structure? That links to your understanding of chemistry. Why aren't the ions in a solid? Why aren't the ions in solid ionic compounds free to move? That links to a real exam question. And especially down here, question 8, why do ionic compounds have high melting and boiling points? So let's just go over the key questions and the answers to recap from last week. So question 2, this is a 2-mark question. An ionic bond is the electrostatic force of attraction between oppositely charged ions. You would get 1 mark for saying electrostatic force of attraction. You would get another mark for saying between oppositely charged ions. So remember that definition. For all those doing A-level chemistry in year 12, this is the same definition even for A-level chemistry. Let's go to question 7. Why are the ions in a molten or an aqueous solution free to move? Well, what's happened is the ions are free to move as the strong electrostatic forces of attraction have been overcome. And this now links to question 8, which is a 3-mark exam question. Why do ionic compounds have high melting and boiling points? Well, this is a classic question that a lot of students tend to get 1 or 2 out of 3. But to get the 3 marks, you need to say strong electrostatic forces of attraction. Okay, strong electrostatic forces of attraction between the ions, 2 marks. And then the 3rd mark is a lot of energy, a lot of heat, or a lot of heat energy is needed to break these forces. So strong electrostatic forces of attraction between the ions is worth 2 marks. A lot of heat energy is needed to break these forces. That is a 3-mark question. So at the end of every video, you have these comprehension and exam style questions to help you really understand chemistry, physics, and biology. So today, we're going to be focusing on covalent bonding, and we're going to be going through what are covalent bonds, how to draw dot and cross diagrams of covalent bonding, especially for oxygen and carbon dioxide, which is where a lot of students struggle. We're going to be doing properties of simple molecules. So what is a simple molecular substance? What's the difference between intermolecular forces and a covalent bond? That is a massive misconception that a lot of students just get stuck on. And because a lot of students don't know the difference, when you get an exam question about the properties of melting of simple molecules, students get that wrong. Why is the melting and boiling point of a simple molecule such as chlorine low, or water low, or carbon dioxide low? So many students get that wrong. And if we have time, I would love to then go through giant covalent structures, summarizing the difference between diamond and graphite. And then this video here literally is the model 6-mark question for describing diamond versus graphite. So let's begin. We're going to go for an hour from now. What are covalent bonds? Well, to understand what covalent bonds are, we need to look at the periodic table. The periodic table contains all of the elements, and you get this periodic table at the back of your exam in your chemistry exam, okay? So don't think you don't get this, and don't think you have to memorize it off by heart. But what you do have to know are the first 20 elements. So hydrogen, helium, lithium, beryllium, boron, all the way up to calcium. You have to know how to draw the electronic configurations of these 20 elements. Remember, the mass number is the bigger number, the atomic number is the smaller number, and there's a stepped line, which if we follow my mouse, we can see that these elements on the right of aluminium, germanium, antimony, they are non-metals, and covalent bonding only happens between these non-metal elements. All of these from aluminium, germanium to the left, they are all metals. So metallic bonding happens in metals. Covalent bonding happens just with non-metals, and ionic bonding happens with metals reacting with non-metals. So it's important to be able to look at the chemical formula of a substance and know straight away what type of bonding does that substance have. So let's go on to what are covalent bonds. Well, to summarize, ionic bonding happens between a metal and a non-metal, and the metal is always the cation, which is formed when metals lose electrons, and the non-metal is always the anion, when the non-metal gains electrons, okay? So that's just a little summary of ionic bonding. But let's now focus on covalent bonding. Well, covalent bonding happens only in non-metals, and here I'm drawing a periodic table. This is the stepped line, and this periodic table contains elements. These are the non-metals to the right of the stepped line, and these are the metals. So if you ever see substances where they only contain these atoms, non-metal atoms, you know that substance contains covalent bonding. For example, hydrogen, carbon dioxide, chlorine, water, H2O, oxygen, O2, hydrogen chloride, HCl. Now, if you forget this, just look at the periodic table. For example, look, carbon and oxygen, carbon dioxide, covalent bonding. Chlorine, H2O as well, water. Chlorine, non-metal. Hydrogen floats by itself. Hydrogen is a non-metal. Hydrogen isn't in any group because it doesn't have the same chemical properties as group 1 metals. So it's not right to put hydrogen above lithium. So that's how you can recognize if a substance has covalent bonding. Let's move on. Question time. So let's check your understanding. In the chat, I would like you please to write 1, 2, or 3 for what you think the answer is. Non-metals are found on the what? Is it 1, 2, or 3? 3, 2, 1. Of course, right of the periodic table. So you find non-metals to the right of the periodic table. Next question. All molecules consist of, so that I never explicitly taught you, but technically, these are molecules because they contain non-metal atoms only. Okay, so if you ever find a substance which contains non-metal atoms only, and these atoms are then bonded with another atom, this is called a molecule. Okay, so all molecules consist of, now that I've told you, it's going to be easy, 1, 2, or 3. Of course, the answer is non-metal. Oh, yes, Israel, back in it. Thank you. Tell all your friends. H2O is a molecule as it is made of what? 1, 2, or 3. You need to remember hydrogen and oxygen, they're both non-metals. Therefore, the answer is 3, non-metals. Okay? Now let's look at hydrogen. Let's now try to understand, how does a covalent bond form? I don't want to just tell you what a covalent bond is. I actually want to take you step by step through what is a covalent bond, okay? And to actually get you to understand it. So this is hydrogen. How do I know that? Well, in the periodic table, hydrogen has the symbol capital H. We can see that just there. If we now move on a little bit, PEN, this is the PEN technique, stands for proton, electrons, and neutrons. Hydrogen has one proton because the atomic number is one electron because the atomic number is one, and then neutrons, we do one take away one equals 0. Okay, so no neutrons. This is the electronic configuration of a hydrogen atom. When you draw the electronic configuration of any atom, you always just draw the symbol first, you draw the first shell, and then you draw how many electrons there are. So a maximum of 2 electrons can fit on the first shell, but hydrogen only has 1 electron. So we're only showing the electron, the 1 electron on the outer, or the only shell there is. You can either use a dot across, some diagrams use small e's, but it's normal practice to use a dot or a cross. Now, this hydrogen atom is not stable. It does not have a full outer shell of electrons. So this hydrogen atom needs to bond with another atom. And how's it going to do that? Well, what happens is, we know the rule is 288, and then at GCSE, you can say 2882, because you only really need to know the electronic configuration up to calcium, but some diagrams, you'll see it go up to bromine and krypton as well. I don't want to go into extra information about that. But look, here we have another atom of hydrogen, and I'm going to draw a dot to represent how this electron is different. So what's going to happen with these 2 hydrogen atoms? Well, neither of them are stable. So if this hydrogen atom were to lose its electron and this hydrogen atom were to gain its electron, that wouldn't really work, because this hydrogen atom, although it would have a full outer shell, this hydrogen atom wouldn't. So that's not really going to happen. So look, they both need 2 electrons for a full outer shell. So what happens is, because they're not stable, they share their outer electrons. And when we draw a dot and cross diagram, we draw the 2 outer shells overlapping. Where the 2 shells overlap, this is the covalent bond right here. Okay, that's the covalent bond right there. And definition of a covalent bond, which is a 2-mark exam question, what is a covalent bond? It's a shared pair of electrons. Okay, so that is a covalent bond. And now if you go around the circle, if you follow it around the circle, this hydrogen atom has 1, 2. If you follow it around the circle, this hydrogen atom has 1, 2 electrons. So both of them now have 2 electrons because they're sharing their outer electron. Okay, and that is the covalent bond, and this molecule is now stable. If we want to draw, or sorry, write, I should say, the molecular formula, it is H2. This means there are 2 atoms bonded, okay, H2. A classic mistake, students write the big 2 at the top, a small 2, sorry, at the top. That is wrong. Never, ever, ever do that. Your 2 needs to be halfway above the line and halfway below, okay? Make it obvious that your 2 is like that, please. A classic mistake, okay? It's question time. The electronic configuration rule is what? Is it 1, 2, or 3? 3, 2, 1. One, number 2, well done. A covalent bond is the what? This is the big one now, 2-mark exam question. 1, 2, or 3? Number 1, well done, shared pair of electrons. Okay, so this is the definition. Covalent bond, a shared pair of electrons. I'm going to move on from this now. Okay, really quickly, does the substance have ionic or covalent bonding? I want you to go back into the video to redo this task. So we're not going to do the questions or the gap fills in this video, but what I am going to do, I'm going to give you 5 seconds and then 5 seconds to pause the answers so that you can go back and rewatch the video, okay? So here are the answers. Ooh, don't want to skip past it. Okay, pause that. Okay, let's move on. Let's now look at fluorine. So ideally, guys, I want you to be having a pen and paper and doing this with me and trying to work ahead. So look, we can see that fluorine, which has the chemical symbol capital F, has 9 protons, 9 electrons, 19 take away 9 equals 10 neutrons. Now, when we draw the electronic configuration diagram of a fluorine atom, okay, we can see that this fluorine atom has 7 electrons in its outer shell, and it needs 8 electrons for a full shell. So it needs 1 electron. It could gain an electron to become a fluoride anion, but we're talking about covalent bonding here. So no electrons are lost or shared. So lost or gained, sorry. No electrons are lost or gained. The electrons are only shared. So here's another fluorine atom. And I've used dots. So this is a dot and cross diagram that we're about to draw. Now with electronic configuration diagrams, you do not have to draw the inner shells. You can just show the outer shell. You do not have to show the inner shells. So I'm going to draw 2 shells that are overlapping. And then as we can see, I've drawn the 2 symbols, 2 shells overlapping. And then this electron and this electron are now going into the overlapping shells where we have the covalent bond. We then draw the rest of the electrons. Done. 2 marks. You would get 1 mark for the correct covalent bond. So if I was marking this, I'll tick that. And then you get another mark for the correct number of electrons in the outer shells. Okay, that's where you get your 2 marks for these kind of diagrams. So always remember, draw the symbols, draw 2 circles overlapping like it's a Venn diagram, if you know what that is, where you have circles overlapping. And then you always, if it's a single covalent bond, you just draw the 2 electrons in the covalent bond, okay? Let's move on. So I'm going to just, here is a gap fill. If you're rewatching this, pause it. The answer is about to follow. Here are the answers. Pause it to go through your answers. And then here are the questions. So pause this to do it in your own time. The answers are about to follow. And here are the answers. And then pause this. Okay, let's move on. We're not going to go over why our covalent bond is strong. Let's move on to, if I'm honest, I actually just want to move on to the hardest dot and cross diagrams to draw now that we've gone through those easier ones, carbon dioxide and oxygen. So oxygen is something that we all know about. We need it to live, okay? Oxygen is involved in respiration and has the chemical formula O2. What elements are in oxygen? Oxygen. How many atoms are there of these oxygen atoms? We can see there are 2. Now, if we look at the periodic table, we can see that oxygen is in group 6, okay? Oxygen is in group 6. So it has 6 electrons in its outer shell. This one, you need to understand that oxygen does not form a single covalent bond. It actually forms a double covalent bond. So look, 6 electrons in the outer shell. It is not stable. The oxygen atom is not stable. So the question is, how does this molecule form a double covalent bond? Well, let's go through it. So a common mistake is this. You draw the circles overlapping, you draw the atoms, and then you draw a single covalent bond thinking, yeah, okay, oxygen has a single covalent bond. That's wrong. Now, 2 electrons represents a single covalent bond. And if you've got 2 electrons, that means there are 5 left for each atom, because 1 and 1 and 1. And then if there are 6 take away 1 for each atom, there are 5 left. So then what happens is we draw the 5 electrons left for each atom. So look, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now let's see if that's correct. So there is 1, 2, 3, 4, 5, 6, 7. If you go around this circle, that means there are 7 electrons. If you go around this oxygen atom, 1, 2, 3, 4, 5, 6, 7. So based on that, each atom has 7 electrons in its outer shell. So it's not stable. This is wrong. I'm showing you a common misconception. Never do it like that, ever, 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 ever. Okay? Israel, an ionic bond is the electrostatic force of attraction, 1 mark, between oppositely charged ions. Okay. Now let's go through how to actually do it. So what you draw the 2 circles overlapping, and look, oxygen has a double covalent bond. That means there are 2 covalent bonds. 1, 2. If I was marking this, I would tick that. Okay, so you'd get 1 mark so far, even if you left the rest of the 2 circles blank. Now, if 2 electrons from each atom has been used, that means there are 4 electrons left now. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, so this is the double covalent bond. Let's see if there are 8 electrons in each outer shell. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. If you didn't understand that, or I went too quickly, go onto the website, rewatch the video, and in your own time, and really try to understand. If you still struggle, because some students do struggle, if I'm honest, you then just need to remember it. Just know that oxygen and carbon dioxide are the only 2 dot and cross diagrams you need to draw with double covalent bonds. Okay, let's move on now. Should be question time now. Yes, that's correct, and that's correct. We've gone through that already. Here is a displayed formula, or also known as structural formula in some books, but really should be called displayed. But GCSE books call it structural. And then here's a simplified dot and cross diagram as well. You can also draw a diagram like this as well. Okay, carbon dioxide. So carbon dioxide has the chemical formula CO2. One carbon atom has 6 protons, 6 electrons, and then 12 take away 6 is 6 neutrons. And we already know about an oxygen atom. Here I'm going to, thank you. Here I'm going to draw a dot and cross, an electron configuration diagram of a carbon atom. And here I'm going to draw the electron configuration diagrams of 2 oxygen atoms, because we know when we look at the chemical formula of carbon dioxide, one carbon, 2 oxygen atoms. Okay, so how do we now draw this as a dot and cross diagram? Well, number one, we don't need to show the inner electrons. We don't need to. And what's going to happen is there are going to be 2 covalent bonds, because carbon is bonding to one oxygen atom and another oxygen atom. So there are going to be 2 covalent bonds, and each covalent bond is going to be a double covalent bond. So firstly, we draw it like this, carbon and then oxygen and oxygen. And then each covalent bond is going to have a double covalent bond. So cross, dot, cross, dot. We know we have 2 outer electrons from carbon, 1, 2. 2 outer electrons from oxygen, 1, 2. In the second covalent bond, we've got this electron, 2 pairs of electrons, a double covalent bond. And then the remaining electrons come from each oxygen atom. 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. So look, let's go over that again. 1 and 2, 1 and 2, 1 and 2, 1 and 2. So all of the electrons on the carbon are bonded. And then there are 2 electrons from each oxygen atom. 1, 2, and then 1, 2. That means there are 4 left. Okay, and these 4 electrons go on this part of the outer shell. Now, if we go around each shell, 1, 2, 3, 4, 5, 6, 7, 8. So the oxygen atom is stable. What about the carbon atom? 1, 2, 3, 4. Go around 5, 6, 7, 8. Stable. What about this oxygen atom? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we can see that each atom has 8 electrons in its outer shell. So again, I'm teaching this to you like we're revising. If this is the first time that you've ever come across this, I would go much slower with you, and I'd give you opportunities to tell me about it. I'd ask questions. I'd want you to draw it out, see where you make mistakes, and you can do that in your own time. Look away from the screen, try and draw it on a piece of paper, write it down on a piece of paper, see if you can understand it, see if it's the same as what's on the screen. If it is, you understand it. If it's not, try again, okay? And then the gap, let's go to the gap fill. I'll give you an opportunity to do this. When you rewatch the video, the answers are coming, and here are the answers. Okay, go through your answers, and then the questions. Okay, the answers are about to come. And then question 5. Okay, pause that and go through it. Perfect. Let's now move on. So I'm doing this in a way where I want you all to go back and do all the questions. So that's the foundations of covalent bonding. I'm not going to go through videos 1, 2, and 4 because they link to what we did in what are covalent bonds, and you can go through that yourself, if I'm honest, because there's not enough time to do absolutely everything. Let's move on. Properties of simple molecules. What is a simple molecular substance? This forms the foundation of understanding covalent bonding. A very important question. All of you need to be able to understand this. So let's just start off with an atom. An atom is the basic building block of all substances, okay? So something we can all relate to is water. We all drink water, I would like to think, every single day. The chemical formula of water is H2O. There are 2 hydrogen atoms and 1 oxygen atom. So 2 hydrogen atoms and 1 oxygen atom. Now, I'm going to teach you why water has a simple molecular substance. And this understanding will apply to why chlorine or carbon dioxide or nitrogen gas or carbon monoxide or methane, why they are all simple molecules as well. Okay, so in a glass of water, there are going to be billions and billions and billions and billions and billions and billions of molecules of water, which can be represented, by this dot and cross diagram. Okay, now these water molecules are not in a long chain. They are all individual water molecules. They are not in a long chain. They are all individual water molecules where they have strong covalent bonds holding the atoms together. Okay, so covalent bonds are strong. It's a massive misconception that people think covalent bonds are weak. Covalent bonds are strong, but these covalent bonds are found between the atoms. Now, this is a molecule because we have a distinct group of atoms bonded by covalent bonds. What I mean by that, by distinct, is that it is an individual, separate molecule from other molecules. So you can easily separate them. So if you put your hand into water, you can get some water in your hand and do whatever you want with it. Okay, because each water molecule is separate, is distinct from the other water molecules. And then we have a group of atoms. We've got 3 atoms here, 2 hydrogen atoms and 1 oxygen atom. And what are they bonded by? Well, they're bonded by single covalent bonds. And we know a covalent bond is a shared pair of electrons. So when we look at this water molecule, we can see there are 3 atoms, 1 oxygen atom and 2 hydrogen atoms. And here are the single covalent bonds, okay? There are the single covalent bonds. So this is a water molecule. And we say this has a simple molecular substance. This is a simple molecular structure, because it's a molecule to begin with. So molecular comes from the word molecule. And we say simple because it means that it's an individual molecule that is by itself. Okay, so simple molecular structure. And structure just talks about how the atoms are arranged. So let's do question time. Atoms are the basic building blocks of 1, 2, 3. What is it? It is 3. Well done. All substances. Molecules are made of this is for both, combined or triple. Molecules are made of atoms bonded by covalent bonds. 2. Molecules are they bonded to many other molecules, distinct and separate, or are they ionic compounds? 1, 2, or 3. The answer is distinct and separate. Very important to understand. Very, very, very important. These molecules are separate from each other. Okay, so let's think about air. Air contains carbon dioxide, oxygen, nitrogen, water, and then other gases such as trace amounts of methane, small amounts of argon, and other noble gases as well. Okay, now when we breathe in air, my lovely diagram, we have carbon dioxide. There is nitrogen, which has a triple covalent bond, oxygen, and water. Okay, so when we inhale this air, these molecules are distinct groups of atoms which are bonded by covalent bonds. Okay, why? Because when we then exhale that air, there is more carbon dioxide in that exhaled air and less oxygen. These molecules are not bonded to each other. Okay, they are not bonded to each other. So we say that these substances or these molecules, they have a simple molecular structure because they are molecules. So the word molecular comes from molecule. They are molecules. So you need to understand what a molecule is. And we say simple because they are very simple structures where they have 2 or 3 or 4 atoms potentially in them. Can obviously, of course, be more as well. Okay, so this is a simple molecular structure. If I'm honest, I kind of just want to move on now because I don't want this video goes into more detail. You can go onto the website and watch the rest of the video. But here is the gap fill. The answers will follow. Here are the answers. Self-assess. Here are the questions. Now, these questions are very foundational. You need to be able to understand this. So question 4, 5, 6, and 7 are more about just focusing on your understanding so you can actually access exam questions in later videos. And here are the answers. So please make sure you get these questions correct. Go over them if you did not understand it. Okay, a very, very important video. Intermolecular forces versus covalent bonds. So you need to know that an intermolecular force, they are weak forces of attraction between the molecules. So here are 2 water molecules. Here are 2 dot and cross diagrams of water molecules, H2O. We know that the covalent bond is in between the atoms, here, 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 and here, in between the atoms. But what force exists in between the molecules? They are called intermolecular forces. Inter, this means between. So inter is a prefix of a word which means between. Molecular comes from the word molecule, and force is just force, push or pull. Okay, so intermolecular force, a force between molecules. That's all it means. So let's look at this diagram now. So here I'm drawing some red lines to represent the intermolecular force between the molecules, okay? It's super, super important you use this language, intermolecular force between the molecules. And there are no sharing of electrons, okay? Very, very key. If when you do, if and when you do chemistry A level, you will learn about this in a lot more detail. But for now at GCSE, you just need to know there are intermolecular forces between the molecules and there are no sharing of electrons. Here I'm pointing to the covalent bond, which is between the atoms. And these covalent bonds are between the atoms where they share a pair of electrons and are very strong. Question time. Let's go. Okay, intermolecular forces exist. Is it 1, 2, or 3? Between molecules. Covalent bonds exist. Is it 1, 2, or 3? The answer is between the atoms. Which is stronger? Come on, please tell me you know this one. 1 or 2? 50-50 chance. Covalent bonds, of course. Okay, so this table just summarizes the differences between covalent bonds and intermolecular forces. I'm just going to skip to the end so you can actually just take down these notes. But the last thing that I do really want to say is that covalent bonds, they require a lot of energy to break. Okay, so that's what you need to know about covalent bonds. They require a lot of energy to break, whereas intermolecular forces, they require very little energy to break because they are weak. Okay, here is the gap fill. Off you go. The answers are about to come. All right, boom, let's go. Here are the answers. Mark it. Okay, onto the questions. You can answer these questions when you go back and watch the video. Okay, the answers will follow. Make sure you're pausing in this time, of course. Okay, here are the answers. Pause it. Let's do this. Okay, I've got a video here which is linked to a 3-mark exam question. Okay, this video is literally linked to a 3-mark exam question. So let's go through it. How are we doing with time? Okay, let's go a little bit faster. Simple molecular substances have low melting and boiling points. So water, which has the chemical formula H2O, we know that these are molecules where they are distinct and separate from each other. In between these molecules, they have weak intermolecular forces, as we can see here. These are weak intermolecular forces between the molecules. So these are weak intermolecular forces between the molecules. Okay, question time. Simple molecular substances have what? Is it 1, 2, or 3? 3, 2, 1, and show. Oh. Low melting and boiling points. Number 3. Molecules have intermolecular forces. Is it 1, 2, or 3? Come on, it is number 3, between the molecules. Okay, so let's continue now. Kind of want to just skip ahead a little bit now to this part of the video. So we know intermolecular forces are weak. Here is a container which is being heated by a Bunsen burner. Okay, and in this container, we have liquid water. The heat causes the water to evaporate. So why is it that the water evaporates so easily? Which is another way of saying, why is it the water has such a low melting and boiling point compared to substances such as diamond or graphite or sodium chloride? Well, this is the language that you need to use. Okay, very little heat is needed to overcome the forces between these molecules. But being super specific now, here is your model answer. So between these molecules, we have intermolecular forces, which are between the molecules. Okay, so we've got intermolecular forces, which are between the molecules, and they are very weak. They require little energy to break or overcome. That there is your model answer for a 3-mark question. Tick, 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 and you get your 3 marks. That's all you need to say. If I was an examiner, I'd be looking for intermolecular force, tick, between the molecules, fantastic. I'll give you another mark. Very weak, marvelous. Little energy needed to break or overcome these forces. That is all you need to say. So again, I'm going a little bit quickly, as if this is revision for your exams. So again, if I went a little bit too fast, go back and watch the videos, okay? Let's go to the gap fill so you can practice using the scientific language. And before we do that, this is the kind of exam question you could get. Why is and they will give you the substance, whether it's chlorine, oxygen, carbon dioxide molecule, a gas at room temperature. So you can now practice that. And then what you can do, you can then go back to the language in the video, okay, right here. That's literally the mark scheme right there. Okay, let's do the gap fill. The answers are coming. Then you have the questions. You lot better be doing these questions after the lesson. Please do them properly. And when you do them, don't be lazy with your answers. Really check every single answer and make sure that you've marked it properly. Okay. Okay. Let's now move on. Properties of molecules, electricity. This is another 3-mark question. Why do molecules? What are their properties when it comes to conducting electricity? Well, they can't conduct electricity. The only molecules that you need to know that can conduct electricity are fullerenes. That is another massive misconception. You have to know that fullerenes can conduct electricity. Okay, they can. Please, please, please don't ever think that they can't. Okay, so simple molecular substances, they cannot conduct electricity. This is a property that you need to know about. So for a substance to conduct electricity, they need to have particles which are free to move, and the particles need to be charged. So a simple molecular substances cannot conduct electricity. And you need to know for any substance to be able to conduct electricity, particles need to be free to move and the particles need to be charged. So let's see out of these requirements, which two, how do simple molecules, how do they not meet these requirements, which is what we're going to find out. So before we do that, here's question time. Simple molecular substances, is it 1, 2, or 3? Cannot conduct electricity. Number 2, of course. Substances only conduct electricity if, is it 1, 2, or 3? Both of the above. Okay, the particles need to be free to move and the particles need to be charged. So let's look at chlorine. Chlorine is not charged. Why? When we look at this dot and cross diagram, we can see that the electrons are shared. Now, chlorine is a gas at room temperature. This means the particles are free to move. So because chlorine is a gas, chlorine is actually free to move. So we can tick off the first requirement. The particles are free to move. So are chlorine molecules charged then? Let's see if they're charged. Well, protons in both atoms, how many are there? Well, one chlorine atom has an atomic number of 17, which means there are 17 protons and 17 electrons. And neutrons are going to be 18 or 20. So if you know about isotopes, you would know that it's going to be 18 or 20. So the protons in both atoms, 17 times 2, we've got 34 protons, which gives us a charge of plus 34. Both atoms, well, 17 times 2 is 34. So 34 protons and 34 electrons, they cancel each other out. So the charge is 0. So molecules, therefore, have no charge. You need to understand that all molecules have no charge because the electrons are shared. No electrons are lost or gained, which means that overall we have the same number of protons and the same number of electrons in every single molecule. Okay, so simple molecular substances cannot conduct electricity, not because the particles are not free to move. The majority of them can. However, the particles, and by this we mean Cl2, they're not charged. And there are no delocalized electrons, and there are no ions. Therefore, the molecules cannot conduct electricity. Okay, 1, 2, or 3. An ion is positive if there are 3, 2, 1, and show. You can tell I'm a teacher when I'm saying show. It's a habit. That's what I say to my class when I'm doing mini whiteboards. An ion is positive if there are less electrons than protons. Okay, an ion is negative if there are. What's it gonna be? Now this is linked to a 2-mark question. Why is an anion negatively charged, or why is a cathode charged? You have to talk about how there are more or less as compared to the protons when you're talking about if something is charged. Okay, an atom is neutral if there are. Easy now. Of course, we know it. We know it. Number 3. Now, can pure water conduct electricity? That is the question. So here I've set up 2 electrodes attached to a power pack. This is the positive terminal, so therefore this is the positive electrode, and this is the negative electrode because this wire is connected between the negative terminal and the negative electrode. And these 2 electrodes have been dipped into pure water, which just means 100% water, no dissolved salts, also known as distilled water. Okay, so this is just H2O. And these molecules are free to move. We know that. And we also know the molecules are not charged, okay? We know they are neutral. We've already explained why. So these molecules have a neutral charge. Now, for electricity to flow around this circuit, the circuit needs to be complete. And the way this happens is that charged particles, such as cations and anions, need to be attracted to these two electrodes. Now, what I'm talking about here is really linked to electrolysis. I'm not going to go into a lot of detail, but if there are negatively charged ions, also known as anions, and they're attracted to the positive electrode, this will allow electrons to flow from the positive electrode to the positive terminal and then around to the negative electrode, where then positive ions, also known as cations, are attracted to the negative electrode and will gain those electrons. However, these water molecules are neutral, they have no charge, so they are not attracted to the electrodes, which is why molecules cannot conduct electricity because they are not charged. They do not have any delocalized electrons, okay, or free electrons. They have no free electrons and they have no free ions. So that's why molecules cannot conduct electricity, okay? They cannot conduct electricity. Off you go. In your own time, when you are doing this video, please pause. And here are the answers. Hope you got full marks. Here are the questions. Doing these questions will really help you understand chemistry, and then as well as help you with your exams, because there are exam style questions in there. What is a covalent bond? Comprehension question. Electric current, that links to physics, especially of course when doing electricity. And then these two questions are exam style questions as well, 6 and 7. And here are the answers. If you can smash these out, you will do well. Okay, we have 15 minutes. Perfect. I'm not going to come on to fullerenes just yet. I may not have time today. We're now going to come on to giant covalent structures. Let's now focus on giant covalent structures. And we're only going to focus on diamond. If you do AQA, silicon dioxide comes up. If you do Edexcel, for instance, and you don't need to know about silicon dioxide, but it doesn't harm you knowing it, because science is science and it will help you just gain a better understanding. So here is a diagram to represent the overall structure of diamond. Okay. These black circles represent the carbon atoms, and diamond is made of 100% carbon. You will not find any other atoms in the structure of diamond. These lines represent the covalent bonds. So these are strong covalent bonds holding together the carbon atoms. Now, we say this is a giant covalent structure because there are going to be billions and trillions and billions and trillions and billions and billions and billions of carbon atoms in this structure that can be bigger or smaller depending on how many carbon atoms are in the structure. Whereas carbon dioxide will only ever have one carbon atom and two oxygen atoms. And between each carbon dioxide molecule and this carbon dioxide molecule is space, where there are intermolecular forces between the molecules, which are weak. Whereas diamond has a giant covalent structure. So we say covalent because there are covalent bonds. We say structure because structure just means how something is arranged and ordered. And then giant because it is a very large structure. Okay. Now let's focus on this carbon atom. You need to know that there are 4 covalent bonds coming out of each carbon atom. 1, 2, 3, 4. Okay. There are 1, 2, 3, 4 covalent bonds coming out of each carbon atom. Okay, there are 4 covalent bonds per carbon atom. Therefore, there is a tetrahedral arrangement. Again, you will go into much more detail about that if you ever do chemistry A level. So overall, diamond has a giant covalent structure where there is a rigid 3D network of atoms, and rigid just means the carbon atoms are held in a fixed position and do not move. 3D means three-dimensional, and network describes how the atoms are essentially spread out in a repeating pattern. So we can actually say, therefore, that diamond has a giant ionic lattice structure and is very hard. This is one of the properties of diamond, that it is very hard. Diamond is the hardest known material to human beings. There is nothing harder in nature. So diamond is the hardest known material. Therefore, diamond can be used on drills because a harder material will cut a softer material. A softer material is not able to cut a harder material. That's one of the fundamental rules of understanding how materials are able to cut other materials. So here I'm drawing a simple diagram. This represents a drill, okay, drilling into the Earth's crust. Here are the people managing this. And what happens is there's actually a lot of friction against the metal and the hard rock, which causes the metal on the drill to bend. Now, to stop that from happening, because the layers of hard rock are so difficult to drill through, we can actually embed the drill with small pieces of diamond. Okay, so the drill is embedded with diamond because the diamond is harder than any rock there is. So the diamond is harder than any rock, which helps the drill to cut into the Earth's crust. Okay, so let's move on a little bit. Question time. Diamond has a what? This isn't on every day, it's on every Tuesday and Thursday, and we're going to be eventually doing physics on a Wednesday as well. So Tuesday will be biology, Wednesday physics, hopefully starting that next week, and chemistry will be on Thursdays. And look out for random sessions as well. Next week, we're going to be doing calculations. So diamond has a good giant covalent structure, easy. Diamond is very hard, easy. In diamond, each carbon atom has what? Is it 1, 2, or 3? Number 3, 4 covalent bonds. Let's go back. 4 covalent bonds. Okay, let's move on now. So these are strong covalent bonds, and a lot of energy is needed to break these strong covalent bonds. Now look how many there are. There are going to be billions and billions and billions of these very strong covalent bonds. So if we want to heat the diamond, and melt the diamond, a lot of heat energy is required to do this because diamond has a very high melting point of around 4,827 degrees Celsius, which is close to the temperature of the surface of the sun. Okay, so diamond has a very high melting point because there are strong covalent bonds which require a lot of energy to break them. Now, there are no delocalized electrons. Okay, no delocalized electrons. Therefore, diamond cannot conduct electricity. Why are there no delocalized electrons? Because carbon is in group 4. Carbon has 4 electrons in its outer shell, and there are 4 covalent bonds where each electron is involved in a covalent bond. So there are no delocalized electrons. Diamond has no delocalized electrons, so cannot conduct electricity. Last point about diamond. Diamond is insoluble in water, so does not dissolve. Okay, it's insoluble in water, so it does not dissolve. All right. Diamond has a what? A high 1, 2, or 3. Hmm. 1 melting point, high melting point. Diamond has, is it 1, 2, or 3? Strong covalent bond, number 2. Okay, this now goes on to silicon dioxide. I'm not going to go over this because it's very similar to diamond, but of course, there are differences, of course. I'm going to move on from this. Here are the questions, to be fair. Here is the gap fill. You can go into the video on the website and get the gap fill without the answers. Here are the questions. Now, something I never explicitly spoke about was what is an allotrope. I'm going to explain that when we look at graphite, okay? Here are the questions, and here are the answers. Now, these questions, they link to real 2 or 3 mark exam questions down here, and these link to a 6 mark exam question on comparing diamond and graphite, as well as also what you need to talk, as well as you can also get a question where you can talk about fullerenes as well. So let's go over graphite. We won't have time to do fullerenes today. Okay, graphite. Here is a structure. This diagram represents the structure of graphite. Now, these black circles represent carbon atoms. Okay, represent carbon atoms. Graphite is made of 100% carbon. Now, something that you need to understand is that diamond and graphite are both made of carbon, yet they have completely different properties. So this diamond is very expensive and can be used for jewelry or they can be embedded on drill bits. And this graphite, we're going to understand why it can be used for electrodes in electrolysis and can also be used, you may not know this, but it's used in pencils. So when you use your pencils and you're writing or drawing with your pencils, there's actually graphite in your pencils. It's not lead. Lead is a metal. Colloquially, we use the term lead just in conversation, but it's actually graphite. So why is it diamond and graphite are both made of 100% carbon atoms, yet they have different properties? Well, it's because they are allotropes of carbon. An allotrope is a substance. Our substance is made of the same type of atoms, but the atoms are arranged differently. So look at graphite. We can see how the graphite is arranged in sheets or layers. So look, here's a sheet, here's a sheet, here's a sheet, or a layer, layer, layer. And look at this. These carbon atoms are bonded to each other, again, by very strong covalent bonds, okay? Very, 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 very strong covalent bonds. But look at each carbon atom. There is 1, 2, 3 covalent bonds per carbon atom. So look, 1, 2, 3, 1, 2, 3 covalent bonds per carbon atom. 1, 2, 3 covalent bonds per carbon atom. This means that when we look at carbon, we know that carbon's in group 4. If there are 3 covalent bonds, that means 1 electron is going to be spare because carbon should be forming 4 single covalent bonds, but only 3 covalent bonds are formed. So there is 1 spare electron. So there are 3 covalent bonds per carbon atom. Okay, and we can see that there are hexagons. These form hexagonal shapes within the sheets. And this is a giant covalent structure because we have covalent bonds between the atoms, and there are billions and billions and billions of carbon atoms bonded together where the size of the substance can change. Okay, question time, let's go. So graphite has 1, 2, or 3. Well done. Number 2, strong covalent bonds. In graphite, each carbon atom is it 1, 2, or 3? Number 3. 3 covalent bonds, easy. Graphite has a 1, 2, or 3. Giant covalent structure, excellent. Now, in more detail, we can see how graphite is arranged in layers, or also known as sheets. Now, this is very important because in between the layers or the sheets, there are weak intermolecular forces, okay? And we already know that these forces are weak. However, graphite does have a very high melting point, okay, because it has a giant covalent structure and the sheets are very close together. Now, when it comes to these sheets, because they have weak intermolecular forces in between them, It means that the sheets can easily slide over each other. So look, here I'm drawing a diagram to represent sheets of paper, and these sheets of paper can easily slide over each other if a force is applied. So look, these layers can easily slide. The key word you need is slide over each other because of the weak intermolecular forces in between the layers, which makes graphite soft and slippery. So graphite can therefore be used as a lubricant, and look, can also be used in pencils. Look at that, that's the graphite in the pencil right there. Question time. Graphite has weak intermolecular forces. Is it 1, 2, or 3? Number 3, in between the layers. Graphite is arranged in layers. Number 2. The weak intermolecular forces means the layers can 1, 2, or 3. Slide over each other. Number 1. Okay, let's move on. So there are 3 covalent bonds between each carbon atom, which means there is 1 delocalized electron per carbon atom. Now, these electrons, they flow through or in between the layers, okay? These electrons, these delocalized electrons move between the layers. Therefore, graphite can conduct electricity. These delocalized electrons are free to move between the layers, so graphite can conduct electricity. Okay, the electrons also transfer thermal energy. So graphite is a good conductor. And we know that these are strong covalent bonds. So graphite has a high melting point. That is all the knowledge you need to know about graphite. Now I'm going to take you to this video right here, summary of diamond versus graphite. This video takes you through everything you need to know, okay, about the language you need for a 6-mark question. It's all right there. If you want to access it, you can go onto the website and you have exam style questions at the end of the videos. If you can answer these questions, you can smash out your exam. So that's the end of covalent bonding. If I'm honest, we can still go over it in a little bit more detail. We can still do fullerenes, but you can just go onto the website and learn that yourself. And then there's next week, we're going to do calculations. We're going to go over the fundamentals of calculations, and we're going to just apply our understanding of moles. So let me just show you what we're going to do. We're going to think about what is relative formula mass, what is the mole, Avogadro's constant, how to calculate moles and masses of elements, how to calculate moles and masses of compounds, empirical formula. I'm not going to do balancing equations. You can actually go onto the website and watch that yourself before. I'm going to expect you to know how to balance equations. What can balanced symbol equations tell you about chemical reactions? And then how to calculate the mass using the balanced equation. That's what we're going to work on next week. And then there's a lot more that we can go through, but there's not enough time to do that. Now, if you guys want to use KayScience, you can use this code online 50 and get 50% off a subscription. Okay, so if you don't want to use it though, you can still sign up to KayScience and get about 20-30% of the videos for free, and all the quizzes are for free. So in every single video, you have these quizzes underneath the videos, okay? So you can actually use these quizzes to help you. And then you've also got a tab at the top called revision tab. Now, I'm not in the student account, so really I should be, to be honest, but you've also got a revision tab, which helps you to revise as well. And then you can go to your My Performance tab and track your progress as well. So again, use Online 50 for 50% off. And these sessions are completely free. So I will see you next week, Thursday, for chemistry at 6:30, and Tuesday for biology, 6:30 again, and then maybe physics on the Wednesday as well. Tell your friends about it. I want to be doing this for free to thousands of students, okay? I want to be doing this for free to thousands of students. So we've got 20 right now. This is the second session. It's at the very beginning. Let's go on a journey together. Okay, I'm going to take you through the whole of chemistry, and we're going to get the grade that you want, whether it's a grade 5 minimum. Ideally, let's go higher, 6, 7, 8, or 9. All right? been lovely, guys. I hope you enjoyed the session. In a bit. Peace.